Hey everybody, my name is Zach Waldron. Today I'm going to be presenting about sourcing pottery, grade clay in Mississippi. This will focus in on areas where ball clay can be found throughout the state. This is for the geography capstone, Contemporary Issues in Geography, taught by Dr. Joby Bass. So here's an outline of what we'll be going over today. First, I'm going to talk about what exactly clay is, why it is important for use in pottery. I'll be going over just a couple pottery traditions in our state. Then I'll be talking about what geologic formations are right for pottery clay. And then I mapped it. I will talk about the steps I took to map pottery grade clay. And then I'll present the map, and then I'll talk a little bit about my results at the end. All right, so what exactly is clay? As you can see here from this chart from the USDA, clay is the finest particle class at 2 micrometers or 0.0002 millimeters. That are formed from the breakdown of rocks, the weathering breakdown of rocks. Some characteristics of clay are it molds together when it becomes wet, it hardens when it's fired, and that makes it perfect for pottery. Mississippi has pretty diverse geology formations that can produce many different types of clay. In this one, I'll be talking primarily about kaolinite rich, what they call ball clay. And my overall goal is to map where pottery grade ball rich clay can be found in the state. So what is ball clay? Well, ball clay is a naturally occurring clay that is rich in the mineral kaolinite, which that's a picture of it in the bottom right there. It's pure kaolinite. It's kaolinite's white in color when it's pure like that, and some characteristics of ball clay or kaolinite rich clay. It's very plastic, it can be molded, has a very fine texture, and that both of those make it the ideal clay for shaping and forming it into pieces and then firing it to get different clay vessels. Ball clay was formed in those ancient floodplains and low slope environments. I'll talk about that in just a couple minutes. And again, that's ball clay is found, or is used, I should say, in fine art pottery. And that on the left there is just some raw clay that somebody dug out of the ground. So before we start talking about the science of clay, I want to talk a little bit about some the modern pottery traditions here in the state. I'm going to focus in on 3 different, famous potters here. The first one and oldest one would be George Orr, who started doing pottery at the end of the 1800s and early 1900s. He was dubbed the Mad Potter of Biloxi. And he's a pretty eccentric guy, if you can't tell by his picture there in the bottom left corner. So he sourced his clay from the rivers of the Chudacabuff River in Biloxi. I read an account from somebody who went out with one of his descendants to the site where he dug clay. It took him 2 hours by a modern boat with an outboard on it to get there. I think, or in the article that I read, they said that trip would have taken him about 2 days to complete by rowboat. So he was really set on getting his pottery and making pottery out of it. And that next picture is one of his pieces. He has some pretty cool art, and he was a little bit ahead of his time, I think. The next one is Peter Anderson. A lot of people know his famous brother Walter Anderson, who for his watercoloring. Uh, but Peter Anderson was the reason the family moved to Ocean Springs to set up his uh, his pottery studio, and that's him at the wheel there. And that next picture is um, a couple of his pieces that he did. And he has some really cool pottery. If you ever get a chance to go to Shearwater Pottery in Ocean Springs, they sell some pieces still, or they sell pieces that his family still makes. He sourced his pottery. I still think they do source some of their pottery from George County. They originally sourced it over in the Fish River in Alabama. The next one is the McCarty Studio in Marigold, Mississippi. They use Yazoo clay. If you know anything about Yazoo clay, it's really red, um, and it holds a lot of water, um, and it actually kind of swells up when it gets water. So, places around Jackson in the Delta, you know, if you've ever driven through Jackson, there's a lot of potholes. Well, it's not really, this city's fault for the most part. A lot of it is because their roads are built on Yazoo clay. Um, they were able to make some pretty nice pieces out of their clay, like that little fish pot. I really like that one. So, as I've already said, the um, powder grade clay can be found is found in the state um, already. And I've described those properties of ball grade clay. Uh, in my research, found that these clays tend to be in different geologic groups and formations. And that's the Wilcox and Claiborne group. And that's the Cockfield, Cook Mountain, Kosciuszko, Zilpha, Winona, and Tallahatchie formations within those groups. And that's off to the right over there is a map, the current map of the geologic formations and groups in our state. Um, as you'll see later on, I've focused on the uh, the light orange, the white, um, the yellows, and the darker brown there in the central part of the state. So within those formations, clays uh, tend to accumulate in low energy and low slope environments that could include that does include river and stream banks, wetlands. I focus on forested wetlands, uh, flat, again, low slope floodplains, and other low slope environments. And again, just slower flowing water. So on the next two slides, I'm going to get a little technical, so bear with me. But here I'm going to talk about the different data that I use in my project. So the first one I use is the United States Geological Survey's Mineral Resource Data System. Um, Out of that one, I got the shape files for the different formations, the Wilcox and Claiborne groups. Um, and then the next one, I got the National Wetland Inventory from the United States Fish and Wildlife Service. That shows the location and the extent of different types of wetlands. And then it has data on the different types of wetlands. Um, then I got the National Hydrography Data Set from the United States Geological Survey. That was within the Living Atlas inside of ARC. Um, that shows every water feature in the United States. Really, I was focused on getting those perennial streams. So that's rivers and streams that kind of constantly flow. Got those polygons out of those. And then I got just the outline from the state of Mississippi, the boundary that is also from the Living Atlas. And again, the goal was to uh, find areas that are rich in ball clay and that are easy to reach for people that want to dig their own clay. So now I'm going to talk about my workflow and that I used to create the map that you will see on the next slide, my final map. So the first step was that I added the data from the mineral data resource system um, and merged them into one study area. Um, and then I added the national wetland inventory data, and since it's so broad, I clipped it to just my study area. And then I removed all the features that I didn't really want, so ponds and lakes, um, and then freshwater emergent wetlands, which are wetlands that hold water most of the time. Um, those would just be too hard, I think, for somebody to go in and dig clay out of without using boats or big heavy machinery. But what I did keep was the forested wetland areas, which is the kind of higher upland or higher wetland areas, I should say. Um, and they're generally have a lower slope, so clay could accumulate in those. Um, Next, I added the national hydrography data to the to my map from the living atlas within the ARC, and then again I clipped that to just my study area. And then I kept just the perennial streams, which again are those streams that flow year round. And then I excluded the intermittent streams, which are streams that really only have water during rain, kind of basically like a ditch. And then I ran an intersect to show where those forested wetlands intersected the perennial streams, because those are areas that are more than likely going to have clay deposits from historical flow and from high water flood events. And then on those perennial streams, I added a 15-meter buffer to account for stream bank. So somewhere within that 15 meters, as you can see there, 49.2 feet. So somewhere within that area will be the stream bank. And those are more likely to have, again, clay that had been deposited historically and through time. And it's probably more than likely going to be at the surface area. Then I merged all of that, or merged the buffered streams with the forested wetlands and the study area, which is the geologic area, or the Wilcox and Clay groups. And then that represents what I think pottery grade clay is likely to be. So here's the final map. As you can see in red there, those are those areas that where the intersect was with the forested and perennial streams. Those are areas that are likely to have that accumulation of pottery grade ball clay. And if you were able to open this up in a web map or an ARC, you could really drill down on those streams and see where clay is likely to accumulate. So now I just want to talk about a couple of the results that I found while making this map. So I was able to calculate up the area of the potential clay area, so that's all the red areas, and found that within all of the formations that there will be about 662.26 square miles of potential clay accumulated zones. And as you can see here on the map, that these areas go from the northern part of the state, northwestern part of the state, down through the central part of the state, and then the east central part of the state. And these actually are in some pretty, highly populated areas. DeSoto County up there at the top have two pretty big population centers of South Haven and Olive Branch. And there's also Oxford and Taylor, Mississippi. Oxford's in Lafayette County. I believe Taylor is in Volusia County. I'd have to go back and check. And you have a little bit of the uh, central part of the state. There's not a lot in there, but a big one, another big population center is Meridian down there in the far east central part of the state. I want to discuss a little bit about this project and where I think it could go in the future. First of all, I didn't do any field work. I really wanted to in the beginning, but time and travel constraints, getting up to that part of the state and be about uh, at minimum 3 hour drive, or up to I think 6 or 7 hours to the northern part of the state. Um, and this clay suitability was mapped based on geology and the research that I did. Again, there was no physical testing because I was unable to do field work. But future work could include visiting some of these areas, going around and doing a little bit of field work and putting some eyes on clay and potentially digging some up and testing it. Maybe even making some pottery out of it. Um, but I really think this could be a good jumping off point for somebody, or even myself, to um, to study in the future. And then I just wanted to add it at the end here that the three potters that I discussed in the beginning, none of them were from areas that were in these groups or formations. Um, they were skilled artisans. They had local knowledge of their area, and they experimented with the clay that they had available to them, and they made beautiful works of art out of it. So that was my project. Thank you, and I look forward to listening to everyone else's. Thanks.